sklearnkernel approximation. Description kernel approximation methods are used to approximate the nonlinear mapping of data into a higher dimensional feature space that is often used in kernel methods like support vector machines SVMs. This approximation makes it possible to use kernel methods efficiently on large data sets. Inputs X the training data. Typically a 2D array where rows represent samples and columns represent features. Y the target values for supervised learning problems, or none for unsupervised learning. Outputs approximated feature representation, a transformed version of the input data. Typically a 2D array with a higher number of features than the original data. Model object the trained kernel approximation model that can be used to transform new data. Steps feature mapping. The kernel approximation method uses a predefined function, e.g., a random Fourier feature mapping to map the original data into a higher dimensional space. Approximation the method then approximates the kernel function, which measures similarity between data points in this higher dimensional space, typically using random projections or other techniques. Metrics accuracy the performance of the model on the task, e.g., classification or regression using the approximated features. Efficiency the computational time and memory usage of the kernel approximation method compared to the original kernel method. Visualization plots scatter plot visualization of the original data and the approximated feature representation. To understand how the method transforms the data. Feature importance plots showing the importance of different features in the approximated representation. Fine-tune parameters. Gamma controls the width of the kernel function, influencing the level of nonlinearity. Number of features determines the dimensionality of the approximated feature space. Uncertainty methods. Ensemble methods using multiple kernel approximation models with different random seeds to estimate the uncertainty in the predictions. Bayesian methods incorporating prior knowledge about the data to derive probabilistic predictions. And uncertainties. Challenges and fixes. Challenge 1 loss of information due to approximation. The kernel approximation may lose some information from the original data, leading to reduced accuracy. Sample use case that resulted in challenge 1 using kernel approximation for image classification, where subtle features are important. Fixes to challenge 1. Increase the number of features in the approximated representation. Use a more sophisticated kernel approximation method. Employ feature engineering techniques to capture important features before applying kernel approximation. Challenge 2. Computational overhead. Kernel approximation can be computationally expensive, especially for large datasets. Sample use case that resulted in challenge 2. Training a kernel SVM with kernel approximation on a large dataset of text documents. Fixes to challenge 2. Optimize the implementation of the kernel approximation method. Use parallel computing techniques to distribute the computation. Consider using a more efficient kernel approximation method, such as Nystrom approximation.